folks! Welcome to my video. I am Jobert Estrada Cantilla from the Bachelor of Secondary Education, major in Sciences 2A. In this video, we are going to comprehensively tackle Ohm's Law, underlying which are the basics of Ohm's Law, how to find the voltage, how to find the resistance, how to find current, the relationship between the voltage, current, and resistance, Ohm's triangle, and a series of problem solving. So, what is Ohm's Law? Ohm's Law is the relationship between three factors, namely voltage, signified by the capital letter V, current, signified by the capital letter I, and resistance, which is signified by the capital letter R. Ohm's Law is pioneered by a German physicist, namely Georg Simon Ohm, by the year 1826, who undertook numerous experiments in physics. These include unbearable agony of experimentally touching live wire with bare hands to measure the electric current. As you can imagine, the greater the current, the more painful it gets. Warning: do not do the mentioned experiment as it is highly insane and lethal. There are three formulas used for Ohm's Law. Voltage equals current times resistance, current equals voltage divided by resistance, and resistance equals voltage divided by current. Wait. This seems pretty complicated, but don't you worry. All you have to remember is the Ohm's triangle, which looks like this. Voltage is measured in the unit of the volt, capital letter V. Current is measured in the unit of the ampere or ohm, capital letter A. Resistance is measured in the unit of ohm, which is signified like this. To find the voltage, just remember the Ohm's triangle, which comprises of letters V, I, R. V on top, I on lower left, and R on the lower right side of the triangle. Since we are looking for voltage, we cover up the letter V, which leaves us with I and R. Therefore, the formula will be V equals I times R, or voltage equals current times resistance. To find the current, we use again the Ohm's triangle. Since we are looking for current indicated by the uppercase I, we cover it, leaving us only with voltage and resistance, or V and R. Therefore, the formula will be I equals V divided by R, or current equals voltage divided by the resistance. To find the resistance, we just have to look again the Ohm's triangle. Since we are looking for resistance indicated by the uppercase R, we cover it, leaving us only with voltage and current, or V and I. Therefore, the formula in finding resistance will be R equals V divided by I, or resistance equals voltage divided by the current. Okay, so let's take this example. We are given this diagram. The first thing we need to do is write the given. The voltage is 10 volts and the resistance is 500 ohms. So we are going to look for the current. We write again the Ohm's triangle and cover I since we are looking for current. So the formula for finding current is I equals V divided by R, or current equals voltage divided by resistance. We substitute the given variables in the formula, giving us I equals 10 volts divided by 500 ohms. Therefore, our current, or I, will be 0.02 amps. So, what is the relationship between current and voltage? Let's take a look at these graphics. Notice that when we double the number of voltage, the number of current also doubles up. From the initial picture, the voltage is 12 volts and the current is 2 amps. When we double the voltage, making it 24, the current also doubles up from the initial 2 amps to 4 amps. Moreover, when we triple the voltage, making it 36 volts, the current also triples up from 2 to 4 to 6 amps. We can conclude that current is therefore directly proportional to voltage. Double the voltage, double the current, which means more electrons are flowing. Remember that voltage is like pressure. It is the driving force in the circuit. It pushes the electrons around the wire, causing the bulb to light up. The greater the voltage, the more electrons can flow in the wire. Okay, so what about the relationship between the current and the resistance? Let's take a look at these graphics. Notice that when we double the number of resistance, the number of current is reduced by half. From the initial graphic, the resistance is 6 ohms and the current is 2 amps. When we double the resistance, making it 12 ohms, the current is reduced by half from 2 amps to only 1 amp. Therefore, we can conclude that current is inversely proportional to resistance. Double the resistance, half the current. Remember that resistance is the opposition to the flow of electrons. It tries to prevent electrons from flowing. That is why we use resistor in circuit to reduce the current and protect components like LED. Okay, let's practice. Find the current using Ohm's triangle. That's it, folks. Thank you very much.